Welcome viewers to the SD online classes. Here today's class we will do class 10 MBSc Mizoram Board of School Education physics portion science of class 10 chapter 1. The name of the chapter is light reflection and refraction. The topic today we are going to do is laws of refraction. You remember there was law of refraction also earlier. So similarly we have this time laws of refraction. Remember the spelling R, okay, F-R-A-C-T, refraction. In laws of refraction, what is the relation between angle incidence and angle of refraction? It was I equal to R in the law of reflection, but it is not I equal to R. You have already seen in the diagram. I have shown in the previous diagram. I is always more than the refracted one. So there is some other relation. That relation is called laws of refraction. Okay, so what is that? Let's write first one. First law is that the incident ray, the refracted ray and the normal to the interface of two transparent media. Media means plural of medium. Media at the point of incidence. All means the three things: incident ray, refracted ray and the normal. All these three lie in the same plane. What is the meaning of this statement? The meaning is this one. Okay, let me show with a pen and pencil. It will maybe easily understood. Suppose this is incident light. This pencil is coming as incident light. Okay, and then you have this is a refracted light. Okay, now and there is one normal line also. This is that normal line. Understand? So you will always have these three things together like this. Incident, okay, this will be like this always. You see, like this straight, they will be like this. So when I join them, it will come together here and they will make, or in the paper if I write, it will be like this: incident, normal. It will never be like this. Understand? Incident here, refracted here. It cannot be like this also. They are not in the same plane. Can you understand? It is up here, it is up here, it is down. It will always in the same. If I sweep them together, they will come together. That is the meaning of same plane. Okay, just like they are in the diagram. This is the meaning of they are in the same plane. This is a simple thing, not difficult. Now the second one is, the second rule is that, so the second law is this, this is important one because this is more used in the numericals. The ratio of the sine, ratio means numerator denominator writing is called ratio. The ratio of sine means sine theta, so like that, SINE, full form is SINE, short form is SIN. Sine of angle of incidence, sine of angle of incidence means this one, sine theta, to the sine of angle of refraction, sine of angle of refraction. This is always same value, constant, same value. If you measure it every time, sine I by sine theta, if you change I from 30 to 40, R will also change and then it will be equal. That is the meaning. Okay, so every time sine I by sine R if you take, that will give you the same value. If it is 30 40, same value will come, 50 40, same value will come, and its value will be same. It is called mu. Pronounce it like this, mu, mu. Okay, mu is the pronunciation of this. This is also called refractive index of the medium. That is our new topic for this. This is called refractive index. Okay, and it is pronounced as mu. This is pronunciation, how to read it, mu. Okay, and this is also called Snell's law. Snell's law, remember the name, Snell's law. Okay, sine value of incidence and divided by sine value of the refraction is equal to a constant. Now sin I is proportional sin R. Okay, how do we know this? Is this law is called Snell's law. So if you plot a graph, okay, if you plot a graph, what you will find it is like this. This is x axis and y axis. If in the x axis you put sin R and in the y axis you put sin R, sin I, you will get a straight line like this, straight line. So this is this one, sin I proportional to sin R. So this will be sin I equal to, proportional to, change it into equal means constant. This will give you sin I by sin R equal to constant, which is called mu, which is called refractive index. Refractive index of the medium, second medium, where the refraction R is going with respect to the first one. That is also important. Okay, so the ability of a transparent medium to bend, how much light it can bend, depends on the refractive index. The refractive index are more, the light will bend more. That is the way of refractive index working. So this is refractive index in terms of speed of light. Here, more the change in velocity, more is the bending. If there is one medium here, okay, light is entering, and if it is not changing much, very little it is changing, that means the speed of light will be very less in change. So suppose if there is a medium like this, enters here and it changes a lot here, changing a lot, that means the speed will be very slow here. There is very little change in the speed. Here is change is very less. Here change in speed is high. If the change in, more the change in velocity, more is the bending. If the light is going, if velocity is slow, very slow after entering in the new medium, the bending will be very high. So that is the meaning of this. Depending on this, you can understand how much is the bending. If the refracted angle is very much different from the angle of incidence, it will be high refractive. Now let us see this. When light enters from air to glass, just like this, air to glass, it bends towards the normal. We all know this, it bends towards the normal, close to the normal. Then the velocity of light, that means what? That means velocity of light is less in the glass. In the air it is more. In this type of case, refracted angle will be less than incident angle. Okay. In the second case, when light enters from glass to air, that what happens, it bends away from the normal, away from normal. That means what? Velocity of light is more in air than in the glass. So in this case, R will be greater than I if this happens. Okay, first you allow from the glass to come out to the air, this will happen. Next topic is relative refractive index. Relative means comparing two different mediums. It is the ratio of speed of light in the medium 1 to the speed of light in the medium 2, and this will be denoted by mu 2 1. Remember, it is not simply mu, it is 2 1. What is this? V1 by V2. So this is what V1 and V2 is. V1 is speed of light in the medium 1, speed of light in the medium 1 is V1, speed of light in the medium 2 is V2. Okay, so in some books they may represent is N21 also, do not confuse. Mu 21 may be represented as this one. In some books they represent 1 here, 2 here, same thing. In some books they represent mu 21, just like in our case, all is equal to V1 by V2. Okay, they are same. Some books they are representing like this, and like this. Okay, similarly the reverse is also true. If you write mu 1 2, that will be V2 by V1. Okay, that will be written as mu 1 2, N1 2 also can write 1 2 like this, they can write. Okay, I will not rewrite all these things. So this is the formula relation. 2 1 means here 1 here 2, 1 2 means here 1 here 2, remember that is the difference. So this is the absolute refractive index. In this case it is same like relative refractive index, but here the first medium, suppose it is air, generally it is air, isn't it? Just in our examples also if you have seen, first one is air, the second one is glass. In those cases relative refractive index become absolute refractive index, because the first one is a standard one, the second one is the more important one. So that is why it is simply represented by mu, sometimes n, in sometimes we will write n water, that means the second medium is water, n oil, the second medium is oil. You don't confuse with n and mu, okay, they are same, right? So it has a different definition also, mu equal to c by v, same previous formula. Speed of light in the first one, speed of light in the second one. First one is air, so speed of light becomes c. So this is speed of light in vacuum, which is c, highest speed, and this is speed of light in medium, this is v, okay. Refractive index cannot have any unit because it is speed by speed, okay, or angle by angle, so it cannot have any unit, so it is unitless quantity. Now we will use it practically and understand. For example, speed of light in water is Vw, suppose 2.25 into 10 to the power 8 meter per second, this is a known thing. Speed of light in the vacuum is this much. Then what will be the refractive index? The formula is c by v. C is 3 into 10 to the power 8, this is 2.25 into 10 to the power 8. If we cancel everything, it will give you 1.33. This is the refractive index of the water. 1.33 is refractive index of water. Similarly, there is another case, in case of glass and air also you can compare. You see here, in the glass speed of light is this much, 2 into 10 to the power 8. See, in water it is slightly more, okay, in glass slightly less, and in the air or vacuum it is always like. So the speed of light here is 3 into 10 to the power 8 meter per second. Then the relative refractive index of the glass, because in the vacuum no need to consider, that is the absolute part. So C is 3 into 10 to the power 8 here, Vg is 2 into 10 to the power 8, so this is 1.5. You understand, here it is more refractive index, so the velocity will be slower here. And you see, here it is less refractive index compared to these two, the velocity will be more. That means in water light travels faster than light travels in glass, so glass refractive index is more compared to the water. That means whichever medium is able to slow down the speed of light, that will be having more refractive index. Very easy. Thank you. Refractive index has other things also to remember, like I'll quickly write this. Mu 21 will be equal to 1 by mu 12. This is the relation, inverse relation between the two. Also, mu 21 is mu 2 by mu 1. Relative refractive index between 2 will be the absolute refractive index by absolute refractive index of both, and the velocity of the first one will be the frequency into the wavelength, okay. So this is the frequency and the wavelength of the medium, right. Thus in terms of wavelength and frequency also you can write, that is mu 21 will be equal to v1 by v2, we know this. We can write mu lambda 1 by mu lambda 2, this is writing in the terms, in terms of wavelength. So mu will be cancelled, mu lambda 1 by lambda 2. So these are the formula we can use for refractive index in the numericals, okay. These are the things you need to know. And another thing very small important is refractive index of violet light is more than refractive index for the red. This for speed of, the speed of all colors of light is same in air or vacuum, but it is different in the denser media, okay. In air, normal air, it is same, but in the, whenever speed of light is measured in the medium, this will be the things you will see. In the violet medium you will see more, in the red medium it will be slow. Okay, it will be less, the refractive index will be less. This is the one.